A very good afternoon. I am Shashwat Singh and I am currently pursuing my BTech at Kalinga Institute of Industrial Technology, Bhubaneswar. Today we shall going to cover the topic which is the general organic chemistry, and under general organic chemistry we will cover a very important effect of general organic chemistry, which is the inductive effect. So we will study inductive effect. So inductive effect, what is inductive effect? Inductive effect is basically an electron displacement effect. So what is it? It is an electron displacement effect. Electron displacement effect. So electron displacement effect, what do we mean by electron displacement effect? It basically means the shifting of electrons. So what does it mean? It basically means the displacement means the shifting of electrons. So shifting of electrons occurs in inductive effect. Now what do we mean by inductive effect? So basically inductive effect is the shifting of electrons which occurs in a sigma bond towards the more electronegative element. So what is it? Inductive effect is the shifting of electrons in a sigma bond, and the electrons should also be sigma electrons because their displacement occurs in a sigma bond, so they are the sigma electrons. So they are the sigma electrons. So and it occurs in a sigma bond. And another point to be noted here is that the inductive effect only occurs in a sigma bond only, does not take place in a pi bond. So sigma bond means single bond. Basically, in easy language, the inductive effect occurs in a single bond. Single bonds. So as we can see, inductive effect is an electron displacement effect. Shifting of electrons occurs in a sigma bond towards more electronegative element. So this is another point, towards more electronegative element. So the shifting occurs towards the more electronegative element. And another thing to be noted about inductive effect is that it is a distance dependent effect. Means it is dependent on the distance. The effect is dependent on the distance. So it basically depends on the distance, and this effect works up to 3 carbon atoms. So up to general, means generally, as we can say, like in most of the questions, up to 3 carbon atoms, this inductive effect is it takes place. So this is the basic understanding about the inductive effect that we have known till now. So now let's take an example of some element. So let's take an example of an element. Suppose carbon, 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 and X. This is an element. So here, as we can see, this is the carbon atoms, and this is an element X. So let's suppose that the electronegativity of X, that is En. En is denoted as the electronegativity. So let's suppose that the electronegativity of X is greater than the electronegativity of carbon. It's greater than the En, that is electronegativity of carbon. This is the case. So what will happen here if electronegativity of X is greater? So there will be shifting of electrons will take place. Why? Because of electronegativity difference. Because of electronegativity electronegativity difference. So because of electronegativity difference, as we can see here, there is an electronegativity difference. So due to this electronegativity difference, then the shifting of electrons will go towards more electronegative atom, because that's what we have studied earlier. So there will be a partial negative charge. What there will be? There will be a partial negative charge on this element X, and there will be a partial positive charge towards on the element carbon. So due to the shifting of electrons, there is a partial development of charge. So another point is that there is a partial development of charges take place. So partial development of charges are taking place in inductive effect, due to which there is a small negative charge on this more electronegative atom, and there is a small positive charge that is developed on the less electronegative atom, that is carbon in this case. So now let's take another example. Let's take carbon, and Y. So we have taken 3 carbon atoms, and we have taken another element Y. So now let's assume that the electronegativity of Y, that is the En of Y, it is less than the electronegativity of carbon in this case. Electronegativity difference is here also, because electronegativity of carbon is more than electronegativity of this element Y, as we have taken in this example. Okay, so due to which there will be partial development of charges. Due to partial development of charges, there will be shifting of electrons that will take place. So how will it take place here? Here it will take place like, it will have, since carbon is more electronegative, therefore shifting of electrons towards carbon. So partial negative charge on carbon and partial positive charge on this element Y. So due to which there will be an inductive effect that will take place in this one. So 2 cases we have taken here. So in 2 cases now we shall see that what is this element called and what is this element called. So as we can see here, this is trying to pull the electrons, as it is the more electronegative element. So since it is trying to pull the electrons, so therefore it is electron withdrawing group. This is electron withdrawing. Like if I explain it in Hindi, electrons को ये खींचेगा, electrons खींचेगा अपनी तरफ. So it will be electron withdrawing group. Electron withdrawing. This is electron withdrawing group. Electron withdrawing group. Can be any element, any electron withdrawing group, that we shall see subsequently. So now this is electron withdrawing group, and it will exhibit which effect? It will exhibit minus I effect. It will exhibit minus I effect. Minus I effect. This is with respect to carbon, because in organic chemistry everything we study is relative to carbon. Okay, so this will exert minus I effect. And talking about this element, this is electron donating group. This is electron donating group. ये if we say this is electron ये देगा, पहले वाला क्या था? इलेक्ट्रॉन विड्रॉ, इलेक्ट्रॉन खींच रहा है अपनी तरफ, एंड दिस इज इलेक्ट्रॉन ये दे रहा है, सामने वाले एलिमेंट को दे रहा है इलेक्ट्रॉन. तो दिस इज इलेक्ट्रॉन डोनेटिंग ग्रुप. This is an electron donating group. This is an electron donating group, and electron donating group, which effect this will exhibit? This will exhibit plus I effect. So this will exhibit plus I effect. So as we can see, there are 2 types of inductive effect that we have seen here. That is the minus I effect, that is exhibited by electron withdrawing groups with respect to carbon. And secondly, we have studied about the plus I effect, that is exhibited by the electron donating groups with respect to carbon. So these are the 2 types of effects. Now we shall study a little bit more about these 2 effects that we have just seen. So so if we take these two effects, which are namely the minus I effect and plus I effect, this will also help us to determine the acidic strength of the compounds, which is also a very integral part of organic chemistry. So which we shall see a bit of it, as there's a time constraint. So first of all, we shall study about the minus I effect. So this is the minus I effect. So minus I effect is basically the electron withdrawing one. This is the electron withdrawing one. So in minus I effect, so we have an order. So the order is, we can see here, like the order is given here. So the order is like this. This is the most the element that exhibits the most electron withdrawing tendency, and after it, the next element that we have is the Nr3 group, Nr3 plus group, and here this is the F, this is the fluorine group, and this is the R group, that is the alkyl group. So, and after that we have the NH2 plus group, and then we have the NO2, and then we have the CN, and then we have the aldehyde group, and then we have the C double bond O and alkyl group, and then we have the carboxylic acid group. So we have the carboxylic acid group, and after that we have the group 17 elements, that is the fluorine, chlorine, bromine, and then iodine, and then we have the OR, like O methyl, O ethyl, like the epoxy groups we have, and then we have the alcohol groups, and then we have the carbon CH, and then we have the C double bond, and then we have the NH2 group, and then we have, at last we have the last elements, that is the phenyl groups, and then CH double bond CH2, and then H. So this is basically the order. In which the elements show the electron withdrawing tendencies. So the most that is the most important example we have is of the NO2 group. So we can take an example, like to decide which is more stable, because inductive effect also helps us to determine the stability of compounds. Like I also told, it helps to determine the acidity of compounds. It also helps us to determine the stability of compounds. So by an example we shall see now, like which is more stable. With the help of this, we have to determine that which compound is more stable than the other one. So for example, we can take an example, like which is if we say that which is more stable. So we have, suppose we have three compounds. Let's suppose that we have NO2, and then we have CH2, and then we have C double bond O minus, and then we have suppose, let's say, CH2 and double bond CH, COO minus, and let's take another third compound, and that we can assume fluorine to be with carbon, and along with that we have the C double bond O minus group. So we have three compounds are there, and we have to determine which is the most stable, or we can also determine the order, like which is more stable, A, B, C, in that order we can we have to say. So how we shall do it? So one important thing while determining the stability of the compounds, the first thing we shall notice is that the more concentrated this charge is, like the more concentrated is the charge is towards an element, so then the more unstable it will be. So this is very important point, like the more distributed the charge is, the more stable the compound will be. and the more the more it is isolated, the charge, the more unstable the compound will be. So here, as we can see, uh, the one compound in which the charge will be can be the most distributed one will be the most stable compound in this case. So we have to see that on the carbon atom, like on C double bond O minus, we have minus charge. Here also we have minus charge. Here also we have minus charge. We have a negative charge on all the three compounds. So how shall we distinguish the stability of compounds? So we can see from this order that here we have this group. Which group? We have this NO2 group. This is O. This is O. This is NO2 group, and rest is the same, and C double bond O minus, and this is the CH2 group, and this is the fluorine group. Okay. So now we have to see, we have studied about two effects, that is the minus I effect and the plus I effect. So in the minus I effect that we are currently studying, so here we have to study electron withdrawing one. Like जो ग्रुप सबसे ज़्यादा इलेक्ट्रॉन खींचेगा अपनी तरफ, that will make the compound more stable. So here in this case NO2 is there, NO2 is exerting minus I effect, NO2 is exerting minus I effect. Here also the carbon is also exerting minus I effect, and here F is the fluorine group is also exerting minus I effect. So all the three groups that we have all are exerting minus I effect. So but based on this order, and how we have decided the order, this is decided on the basis of the acidity values or the stability values. So that is a topic of further discussion, but this is the order that is pre-decided. So according to this order, NO2 has the maximum minus I effect, so it will the electron withdrawing tendency, electron को अपनी तरफ खींचने की tendency will be the most in this group. Okay, and after that we have this fluorine group, because after NO2 we have this fluorine group with us in this order, as we can see, and at last we have this CH2 group. We have this CH2 group. So we have this CH2 group here. So on the basis of minus I effect, the NO2 will stabilize the negative charge the most, because सबसे ज़्यादा ये इलेक्ट्रॉन को खींचेगा अपनी तरफ. So and after that the fluorine will stabilize this negative charge the most, because after NO2 we have fluorine, and at last we have this CH2 one, CH double bond CH2. This will exhibit the least minus I effect. So due to the least minus I effect, it will not be able to properly stabilize the negative charge. So what will be the order? The most stable will be the A compound, and then after that we will have the most stable as C, and then we have the least stable as B. So this is the order of stability that we can see on the basis of minus I effect that we have completed here. Time